In this somewhat quick video, we're going to look at the zeros of polynomials functions, but in specifics, we're going to look at some of the properties of the roots. If a polynomial equation is of degree n, then counting multiple roots separately, the equation has n roots. What that means is if I have 2 that occurs twice because x minus 2 is squared, I'm going to still count that as 2 roots instead of 1 double root. And I'll have exactly the same number of roots that I had a degree on the polynomial. Second nice neat little property. If a plus bi is a root of a polynomial equation with real coefficients, of course b not equaling 0, then the imaginary number a minus bi is also a root. Imaginary roots, if they exist, occur in conjugate pairs. So if 2 minus 5i is a root, 2 plus 5 is also a root. So let's take a look at how some of that just might help me through something with a 4th degree polynomial. First of all, I'm going to use my rational root theorem and say it's 1 and 13 are the factors of my constant term. 1 is the only factor of my lead coefficient. So 1 over 1 and 13 over 1, but I got to consider both positive and negative. So I have a total of 4 numbers that could be rational roots. And guys, if I don't find a rational root, I've got a mess here to try to solve. So I'm hoping that one of those will work. As always, I start with 1, and sometimes I get discouraged and start somewhere else. And when I do, that's when 1 is my 0. So I'm just going to start with 1, and we're going to go in a nice, neat order. And 1 times 1 is 1, minus 6 is negative 5. 1 times negative 5 is negative 5, plus 22 is 17. 1 times 17 is 17, minus 30 is negative 13, and lo and behold, looky here, I'm glad I didn't skip him, 1 was a 0. Okay, so I found 1. But that knocks this from a 4th degree to a 3rd degree. I still don't think I can group that thing and make it work. So, I'm going to put me a little box right here. I'm going to try 1 again, just see if I can get lucky. 1 times 1 is 1, minus 5 is negative 4. 1 times negative 4 is negative 4. Oh my goodness, can't believe this worked. 17 minus 4 is 13. 1 times 13 is 13. I just found a second 0. And now I am down to x squared minus 4x plus 13 equals 0. I try a quick tic-tac-toe. 1 times 13 is 13. Factors of 13 that add to give me 4, it's not happening. So it's not going to be rational. These are going to be either irrational or complex. How do I find out? Well, since it's 1 and even, I want to solve by completing the square. So I'm going to leave my 4x over here with the x squared. I'm going to leave myself space to add something. I'm going to say since it was plus 13 on the left, it's minus 13 on the right. And I'm going to leave myself for that same plus what? Well, I come down and I say x minus. Half of 4 is 2, but 2 has to pass through the square to become 4 on the line above it. And negative 13 plus 4 is negative 9. So since they squared it, I'm going to take positive and negative square root. That is to say positive and negative square root of negative 9. I'm going to go ahead and simplify him. That's going to be x minus 2 equals positive and negative 3i. Since they said minus 2, I say plus 2. So it's 2 plus or minus 3i. So I have my 4 zeros. Here's 1, 2, 3, and 4 still kind of written together. So let me put them out. My zeros are 1, multiplicity 2, 2 minus 3i, and 2 plus 3i. So although the 1 being a double root shows up twice, I'm not looking at 3 and going, ooh, I've still got a 4th one out there. It was a double root, so I do count him twice. I found all 4 possible answers, and I see that my complex answers do show up in conjugate pairs.